sum and difference for sine. So, suppose you want to take sine of an angle A plus angle B. I would think that the most intuitive thing for people is to take sine of angle A plus B and write it as sine of angle A plus the sine of angle B. And they would use what we call the distributive property. That is 100% incorrect. It is voodoo math. Okay? We could use some of our trigonometric identities, and we could prove that this is actually equal to something else. The way you see what sine of A plus B is equal to is you do sine of A times the cosine of B. And then you add that on to the sine of B times the cosine of A. Now again, if we look back at our formula sheet, you can see that that formula is listed right here. I maybe switch the sine of B and cosine of A. It doesn't matter. Multiplication is commutative. It's fine. It'll work out. As you can see, your formula sheet has a plus and a minus. And so what that means is as you look back at the beginning, it does say sum and difference formula. So if it's sum, it stays sum here. If it's difference, it's difference down here. But cosine is different. Cosine of A plus B. Again, on the test, you might write cosine of A plus cosine of B. Again, I'll be very angry when I see that. Nothing says that we can distribute the operation of sine and cosine. It's not multiplication. It's a different operation. Times, divide, plus, subtract. Those are operations. So is sine of something. It's an operation. It's not one of those. So the properties of distribution don't necessarily hold up. So what this is equal to is the cosine of angle A times the cosine of angle B. And instead of plus, it switches to minus. Sine of angle A, sine of angle B. Exactly. So suppose it was minus here, then it would be plus down there. So all sorts of new boundaries during this unit. Maybe the first time you've ever seen a minus plus symbol. You've seen plus minus before, but there, behold it, minus plus. Kind of special, huh? Just make sure we all understand. Look back at your sheet. Here it's plus minus, and it switches to minus plus. Does everybody see that? Okay? All right, so let's try the example. It says, find the exact value of the following. And by exact, that means that you must use your knowledge of trigonometric formulas in order to find the exact value. For example, if you were to write down 0.7071, that might be a really close answer, but the exact value for 0.7071 is the square root of 2 over 2. For this, I award you 0 points. For this, I award you 3 points. Okay? So, you must give me the exact value. I do each year have people that argue that with me, and bring in a panel of teachers and tell you what they think. So if we argue too much, it just might start subtracting points. So, all right, find the exact value of the following: sine of 23, cosine of 67, cosine of 23, sine of 67. Ooh, looks kind of disgusting, huh? Do you know the exact value of sine of 23 degrees? Can you give me an angle that you know the exact value of sine of? Sine of 90 is 1. How did you know that? Some of you knew that, some of you didn't. Do you remember that? Do you remember that if we have a 30-degree angle, do you remember that this is 1, that this is the square root of 3 over 2, and this is 1/2? So therefore, this has a terminal point of root of 3 over 2 and 1/2. What is the terminal point here? 1, 0. What's the terminal point here? That's how they knew that the sine of 90 was 1. because they know sine is the y value. Do you remember if I have a 45, 45, 90 triangle, what the terminal point is? Root 2 over 2, root of 2 over 2. Remember if I have a 60-degree angle, what the terminal point is? Okay, you had 2 assignments where you created these and you tested on it. You have to be able to do this on your own during this unit as well. If you're able to remember these values, great. So if I ask you what the sine of 60 is, you know it's the root of 3 over 2, good. You don't have to make that. But if you don't know those values, then you're going to have to construct it on your own. So the more you can remember those things and commit them to memory, the better off you'll be. So we know the exact values of things like 30 degrees, 45 degrees, 60 degrees, 90 degrees, 0 degrees, so on and so forth. But we do not know the exact value of sine of 23. So, does this look like something we've already written? What does it look like? Yeah, it looks like sine of an angle A times cosine of an angle B plus the cosine of an angle A times the sine of an angle B. And what did we say that's equal to? The sine of A plus B. Well, in this problem, what is the value for A? 23. What's the value for B? So therefore, this expression can be written as the sine of 23 plus 67. What is 23 plus 67? 90. What's the sine of 90 degrees? No big deal, huh? Not too bad. What? 2 questions. What? What? This side? This side. This is this. They are the same things. And so what I've done is I've said this, instead of using this piece, I will use this instead. So I just decided what the A value was and the B value was. Because I know how to simplify that. I don't know how to simplify that. I don't know what the exact value of sine of 23 is. But I do know the sine of 90. So because I was able to write it like this, I could then do it. Okay, let's look at the next one. Next one is in radians. No big deal. Which one does it look like up there? Yeah, it's the cosine of an angle B times the cosine of, angle A, cosine of angle B, plus the sine of angle A times the sine of angle B. And we know according to our formula that that's equal to what? A minus B. Thank you. So it switches for cosine. Instead of using the plus sign, we're going to use the minus sign. So instead of writing this in that form, I want to write it like this in this form. What is angle A in the problem? And what is angle B? So therefore, this expression right here can be written as cosine of 2 pi over 3 minus 5 pi over 12. How do I do 2 pi over 3 minus 5 pi over 12? Common denominator. So common denominator would be 12. So I get 8 pi over 12 minus 5 pi over 12. 3 pi over 12. What's 3 pi over 12? So I have the cosine of pi over 4. Pi over 4 is how many degrees? 45. What is the terminal point for 45, 45, 90? Is cosine the x value or the y value? Cosine is the x value. So the exact value is root of 2 over 2. Again, if you write 0.7071, I give you 0 points. This, 3 points. Okay, just two more examples. Find the exact value of the following. When I made my little chart up here, did we see a 15-degree angle? No. But what I'd like to do is find the exact value of sine of a 15-degree angle. Well, it seems impossible. I mean, when you talked about special triangles back in geometry, you talked about 60, 60, 60, correct? You also talked about 45, 45, 90, right? You also talked about 30, 60, 90, right? Did one ever come up with 15 degrees? No. So let's use trig. Can somebody tell me two angles that either add to 15 or subtract to 15 that we do know the exact values of? 60 and 45, or 30 and 45, or 135 and 120. You have all sorts of options. So you could choose the 60 minus 45. You could choose the 45 minus 30. It doesn't matter. As long as the two angles subtract to that degree, you're fine. So remember, I will write this out. This is the sine of angle A times the cosine of angle B minus the sine of angle B times the cosine of angle A. What is A? 45. What is B? Let's simplify this to find the exact value. What is the sine of 45 degrees? Look back at my special triangle. Sine is the y value, so root of 2 over 2. Cosine of 30, cosine is the x value, so it would be square root of 3 over 2. Sine is the y value. We're doing cosine of 30. Minus sine of 30. Half cosine. Multiply them. Are you allowed to multiply these? Yep, you get square root of over. Sorry, I made that mistake before. Square root of 2 over 4. Hey, they got common denominators. That's the exact value. Yo. Yep, you either need to memorize it or draw it out. So if we construct, say, in this case, we did 30, right? 45 and 30. So I'll draw a 45 and a 30. First of all, my unit circle, I know that this is 1, 0. I know that this is 0, 1, right? And I will start with a 45, 45, 90 triangle. What is the radius? 1. I get this side by dividing by the root of 2. 1 over the root of 2, which is the root of 2 over 2. The 45, 45, 90, those sides are the same. So this terminal point is root of 2 over 2, root of 2 over 2. Sine is the y value, cosine is the x value, and tangent is y over x. If you want to do the 30-degree one, that's 1, that's half, and you multiply this by the root of 3 to get the root of 3 over 2. So that coordinate is the root of 3 over 2, 1 half. Cosine is the x, sine is the y, tangent is y over x. You do the same thing to get the 60-degree angle. Okay. All right. We try the next one. Oh, where are we? Hey, the exact value. Square root of 6 minus square root of 2 all over 4. Now you say no big deal. Why? Because you can just hit your calculator and punch in sine of 15 and it gives you a value. Well, that's only been able to do that for the past 50 years that we've had the calculator that can do that. Your calculator has to use a lot of calculus in order to figure that out. So back in 700 BC, when the Babylonians were trying to model the orbits of the planets and figure out how far we were away from it, you can actually find tablets that have sine values calculated on them. Yeah. I mean, well, I'm not saying they did the same thing that we did, but the fact is that once they knew the sine of 30 or the sine of 15, you're able to hopefully come up with better values. They had different methods of approximation, but my point is, people, is that they used to do this all of the time. I majored in ancient studies. All right, next one. Most of you would rather not work with radians, so we'll flip it to degrees. So 7 pi over 12, how many degrees? Ooh. Times 180 over pi, the pi's cancel. 180 divided by 12 is 15, times 7 is 105. So what are two angles that either add or subtract to 105? What'd you say? 135 minus 30. That would work, yep. Yep. We don't know 15. Well, I guess we kind of do now. But we'd also have to figure out cosine. That would be a lot of work. How about 60 and 45? You can use 135 and 30. That's absolutely fine. I'm going to use 60 and 45. Okay, so I'm going to write this as the cosine of 60 degrees plus 45 degrees. And by the way, you guys, the problems we're doing right now, these are the problems that you should expect to get right on your test. Okay? I would say these are some of the 4-level problems. Well, because you have to come up with 105. If it was minus, you'd come up with 15. All right, well, I know what that looks like. That looks like the cosine of A times the cosine of B minus sine of A times the sine of B. Okay? All right, so I plug in 60 for A, 45 for B. 60 for A, 45 for B. So, good thing that we just drew our nice little unit circle guy right here, right? We didn't put on the 60-degree angle one, but we sure could, and figure out that coordinate is 1/2 and the root of 3 over 2. Okay. So we go back here, and we have cosine of 60 is 1/2. Cosine of 45. Sine of 60. Sine of 45. So I get the root of 2 minus the root of 6 all over 4. Does that look similar to the last one? Is it the same as the last one? It's not the same, but it's similar. Let's think about it real quick, okay? Let's try to think about this. Is the one in red going to be positive or negative? It's going to be positive. Let's look at the angle. 15 degrees. First quadrant, second quadrant. First quadrant is sine positive or negative in the first quadrant. So you can see we do come up with a positive result. Let's look at the next one. Positive or negative? Negative, because the square root of 6 is bigger than the square root of 2. Is 105 in the first or second quadrant? Second quadrant. Is cosine positive or negative in the second quadrant? Negative. So you can see it works out. Isn't that slick? Try to find ways to check your answers. So today we did sine and cosine on, tomorrow you have a work day in class. Wednesday or Thursday you have a work day on your, we're going to review for the final. And then Friday you have a final. So on Monday we get to this piece, okay? Okay, I wrote down the wrong assignment originally from first or third hour. Okay, so you want to write down 7.2, page 548, numbers 1 through 3, 6, 7, 9, 10, 11 through 13, and 16. Before I start answering questions, I just want to make sure that you don't get confused when you get to your assignment. Let's say your assignment does something really tricky, and it says, well, you got to know what the cosine of negative 15 is. Oh no, they threw in a negative. Let's remember, what happens to the negative angle for cosine? You just flip it to this. Okay, yep, the even and odd identities. That tells you you can just get rid of the negative for cosine, and now you can do that problem instead. Suppose you have sine of a negative, what would you do? Yeah, so just do the sine of 15 degrees, and then just make the answer negative. Or if you wanted to do 30 minus 45, you can still do that as well. So it's up to you, okay? All right, first question, second question, and shut this down.